Good evening, students. We are in the last part of Unit 1 to explore about the degrees of freedom and continuous and batch process. Let us explore first one. So here, let us see how to determine the degrees of freedom. F is equal to number of variables minus number of equation, which is represented as P minus E. Next, there are three cases to distinguish this following case. One is f is equal to 0, another one is f is greater than 0, another one is f is less than 0. It is very clear that you will get a unique solution when f is equal to 0 because number of variables is equal to number of equations. So there will be a unique value for this case. And second case, f is greater than 0, you call that as underspecified. So you will have a multiple solution because f is greater than 0, so number of variables is always greater than number of equations. So arbitrarily you have to, we can specify the arbitrary f of variables. In that case, you have to include the additional variables equations to have a unique solution. And last one is f is less than 0, we have more equation than the variable. In that case, there is no solution. And in this case, we have to say the system is over specified. You need to reduce or remove the solution for remove the equations to arrive the solution. Okay, so the degrees of freedom plays a very important role in design of controller. So when you want to achieve a desired control, you need to specify what kind of degrees of freedom is that, how many degrees of freedom for a particular system. That degrees of freedom is determined based on the number of values minus number of equations. So it may be either exactly specified or it may be over specified, or if it is under specified. Right. So coming to the next one, which is nothing but the uh, batch and continuous process. Okay, so batch process, what do you mean by batch process? When the process is when there is a single job operation, you call that as a batch process. When you go for a mass production, you call that as a continuous process. Example is the handmade detail or complex piece of furniture, or if you take a mass production car, is a manufacturing of a. Okay, so for a batch process, it is not required to feed the raw material continuously, whereas a continuous process, you have to feed the raw material continuously. Okay, so here we need to limited number of items has to be feeded. So you can see the picture representing the batch process because it is going to have a series of operation which is operated in a batch wise, not a continuous wise. Whereas when you take a continuous process, so right from the raw material to the finished product, everything is continuous. Okay, so it is good, the plant is going to run continuously 24/7. Okay, so here are some of the examples representing the continuous and batch process. So if you take a continuous process, you can see there is a heat exchanger, CSGR, cracking unit, and multi component distillation column. Okay, so it represents a heat exchanger. You have a process fluid, cooling medium. Always there is a cooling medium we have to pass because there is a transfer of heat from one substance to another substance. When you take a chemical reactor, there will be a reagent will be there, there will be a mixer is there is a cooling medium which is surrounding the reactor, and there will be a product will be there. And if you take a cracking unit, you will have a crude oil, cracked products. Okay, and finally the distillation column, if you give a feed, it is going to separate that as a bottom product and top product. And similarly, when you take a batch process, the example is it is used everywhere. Okay, so for example, the best example is a kidney dialysis unit. If you pass the impure blood and through a dialysis medium, you can convert that to a pure blood. Okay, or there is a semi batch reactor where the same operation is done but it is not done continuously. Or you can take a wood chip digester. Okay, so where wood chip okay, you are going to do some process for digestion, that is steam plus sodium hydroxide to have a digester. Okay, and even if you take a semiconductor manufacturer, there is a plasma etcher is there, so there is a electrode is there, you have to paste over the wafer, and there will be a etching gases will be there where you are going to have the plasma etcher. Okay, so these are some of the examples representing the continuous and batch process. Thank you, students.